We've been working on potassium in North Carolina now for 3 years, and I'm going to share with you some of the information that we found out with that work this morning. Kind of an overview of where we're going, just a review of K in the soil and the plant, uptake and removal, a few slides on that, the research results from a soil plant and yield data, spend a little time with that, and then our recommendations. Is a revision needed for our recommendations for potassium in North Carolina. Potassium in the soil, as you know, it's attached to the C. C is a cation. It's positively charged with 1+. It's usually 10% or less of the CEC, at least in North Carolina soils, and I expect in y'all's soils too. I think most of y'all have sandier soils, or those in eastern Maryland have sandier soils. Held less tightly than calcium magnesium, so it can leach. And we see leaching in our sandy soils in North Carolina. I also think I see leaching some organic soils because of the calcium-magnesium competition at times. You know it exchanges into the soil and the water where plant uptake occurs. Uptake and movement in the soil is diffusion-driven. So oftentimes we see potassium deficiency under droughty conditions. So when you stop the water flow, you stop diffusion, you see deficiency occur. Sometimes that will go away with good moisture when that moisture comes back. Functions in the plant. We know it controls the gas regulation in the plant, controls the guard cells. If you remember the guard cells and their function in the plant, it's essential for photosynthesis. Also the synthesis and transport of sugars. We oftentimes remember it's important for lodging and stalk strength and structure, and we've seen that here. This is from our field data this past year down in the lower right corner. That's a zero rated potassium at a fairly low soil test level. So you can see that corn is blown over. We also know in some crops it's important in lowering the incidence of disease. If we look at uptake in the plant and we compare corn and soybeans, this is a slide coming out of data showing uptake of fairly new varieties. It's published paper in the Agronomy Journal. And the important take-home point here to notice would be with soybeans at R2, we're looking at about 30% of the uptake occurring by R2. So soybeans is really a late feeder. It is not an early feeder of potassium. As opposed to corn at R2, we've seen about 80 to 85% of the uptake occurring. So corn is a very early feeder of potassium. So I think that's important for us to remember as we manage this nutrient. Uptake and removal. Here we have corn, the crops. Uptake pound per unit. Removal pound per unit. Removal for a given amount of yield here. I threw in some data. I know y'all don't have much interest in cotton and tobacco, but for other audiences it can be appropriate and useful. So we'll focus on corn, soybeans, and wheat. You can see here for a 200 bushel corn crop, we're pulling off about 50 pounds per acre. For a 50 bushel soybean crop, about 60 pounds per acre. And for a 100 bushel small grain crop wheat, 29 pounds per acre. Now 50 bushels of beans, that's certainly an admirable goal, but some people are pushing 75 and 80 and 90. So when you look at those kind of yields, this number will increase drastically. So soybeans consumes a lot of potassium is kind of the take-home message of this, certainly depending upon the yield. When we had potassium deficiency in the soil from a plant standpoint and what we see shorter plants, we see yellowing of the leaf margins. Sometimes this will become necrotic. Usually potassium is mobile in the plant, so oftentimes this will occur on the lower leaves as that potassium goes to the growing point and moves. We see more narrow, shorter leaves, delayed vegetative development, delayed tasseling and silking in corn, and I'll show you a good example of that in a few minutes. Purple staining in soybeans is known to increase under low potassium conditions. Increased lodging and certainly yield can be affected too by low K. This is one of our sites, one of the lowest potassium sites we had. This is actually a mountain site. These pictures were taken the same day. This is 0 K. Notice the lack of development in that plant compared to 200 pounds per K. These are exactly the same day. So delayed maturity, delayed development, we saw it in our field work. Just some shots of potassium deficiency in soybeans and corn. Oftentimes you will see this later in the season too, in the upper part of the plant. These are shots here showing that. Corn, here on the lower leaf, you'll notice the necrosis and yellowing of the leaf margins and also the tip of the leaf. If this was nitrogen in corn, you would see it up through the mid vein. So that's how you could tell the difference between nitrogen and potassium in this. This is just an ugly tobacco plant here with potassium deficiency and some other things going on too. So why is this research needed? Well, in North Carolina for soybeans, our annual acreage is about 1.6 million acres. We know that over the years we've had advances in genetics. We've had grower production practices change tremendously over the years, in my lifetime and probably your lifetimes too. We know we've got higher yields achieved today. Here, this dates back to 1950s, and this is the National Ag Stats data. We were at 18.5 bushels per acre. We jumped to present day and we've increased, this is statewide average yield data, to 34 bushels per acre. Quite an increase in yield for that time period. So with those higher yields, we have more crop removal. That just makes sense. It has been decades in North Carolina since we've really evaluated our soil potassium recommendations. And actually, we are a Malik 3 lab, Malik 3 soil testing extractant, and I cannot go back into publications and find any Malik 3 work with potassium in soybeans or corn. So this was critical for us to evaluate. If you think back a few years ago, we saw some very high potassium prices. 19% of the production costs were related to potassium in soybeans. So growers are spending a lot of money on K fertilizer. If deficient, we know that yield losses can range to 5 to 20%. You can think about that with decreased pod number, decreased seeds per pod, and decreased seed weight. These data come out of Arkansas. Parvey was in Arkansas for a number of years, and then he moved to Virginia Tech, and I'm not sure where he is now today, but he did a lot of work on potassium in soybeans. So our objectives for this study were to characterize our yield response to potassium. We looked at different soil types, different tillage systems, and also different management systems. We wanted to determine the accuracy of existing Malik 3 soil test recommendations to maximize yields. So we wanted to kind of validate if we were recommending enough. We also had two other objectives down here that we won't discuss today, but they were certainly important with our research. So looking at our sites in 2016 and 17, we also had work in 2018, which I will not share with you, and we'll focus primarily on the 2017 work. We had sites across the state. Most of those were focused in the coastal plain part of the state. We had one site in the sandhills at a research station, and we had two sites in the mountains on a research station. Otherwise, these sites tended to be on-farm test cooperators. And these farmers usually were chosen oftentimes with consultants behind their operations too. One thing that made it difficult in site selection was trying to find high-yielding sites with low soil test K. That is a great challenge for us. So most of our sites tested on the lower end of a medium soil test level into the high level soil test. Looking at some of the site characteristics, this is 2017 in soybeans. Important for you to pick out probably is CEC. We had CECs down here around 3 and as high as 17. Norfolk is a loamy sand soil that's highly productive, utilized a lot in various cropping scenarios, and it's one we like to focus on in our work. But we had this state soil with a CEC of less than 3. So definitely some leaching potential with these soils. We also had irrigated sites. So we had some room for pushing the yield envelope or trying to avoid drought stress from that standpoint. Just to show you a couple of contrasting soils we work with, this is an organic soil. We have a lot of these in eastern North Carolina, especially the Tidewater region of our state. A lot of mucky material, not much mineral material, sand, silt, and clay, but tremendous CECs. In contrast, this is our Norfolk soil with a loamy sand AP horizon or surface layer, and then we actually see some increase in clay content, and we can find substantial potassium in this subsoil K where it's leached from the topsoil at times. Management of soybeans in 2017. You can see the previous crop, a wide range of crops here. This is tobacco wheat cover crop is what that stands for. This is on a research station, so that's why peaches was the previous crop there. We had a number of different varieties here with different growth habits. We are growing quite a few indeterminate soybeans in North Carolina as well as determinates, a wide range of row spacings and tillage. C is conventional till, this is vertical tillage and no tillage, this is reduced tillage is what these letters mean. So a wide range of grower production practices. In corn in 2017, again, focus on the CECs. With corn, certainly growers are not growing it on the most sandy soils in North Carolina, so you can see we had CECs a bit higher for that. We also had a number of sites that were irrigated, important to note as well. This is the Mountain Hort Research Station site. Very productive soil in this field. We can push 300 bushel yields in this field. Very low K. So it was a great site for us to look at. It is a floodplain site. You can see the creek boundary around the field. This is the Candor Sand site. We didn't have corn on this site, but we had soybeans there for 2 years. CECs here, very, very low. This was an irrigated site as well, but mostly sand throughout this horizon here. The management for corn, again, a lot of different row spacings and also planting dates and tillage types for what growers were using. Okay, let's jump into the experiment of what we actually did. We have 5 treatments at 50-pound increments from 0 to 200 pounds per acre. The source here was muriate of potash. The treatments were broadcast hand applied. You could say they were precision GPS applied by Carl Crozier. He's my partner in crime. He's doing the job there for us. And we had 4 to 8 row plots depending upon the site. This is just showing the outline of a site as we would have it in the Mountain Hort research stations, and typically we laid them out 4 blocks with the treatments going across and randomized throughout the blocks, going front to back normally, depending upon the field. Soil sampling. The initial sampling was done by depth prior to K application. So the day we set the test out and laid it out, we soil sampled with depth at 0 to 6, 6 to 12, or 12 to 18 inches for conventional tillage. For other tillage types, we did 0 to 4, 4 to 8, 8 to 12. After treatment, we came back in and sampled by depth again. So this was a lot of hard work for us, believe it or not. We did this for soybeans at V3 or V5 growth stage, and at corn we targeted V5 to V7. We wanted to verify the increased level in soil test K after application was the reason for doing that, and also look at the amount that leached down into the profile after we applied it at a certain time period. Plant tissue for soybeans. In 2016, we sampled the whole plant at V3, very, very early growth. And then at V5, R2, and R5, we sampled the most recently mature leaf. Since we didn't really see much at V3, we changed our strategy in 2017. We only sampled at V5 and at R2, the most recently mature leaf. And that would be in this picture here, that leaf right there, about the 4th or 5th lead down from the terminal in the plant. In corn, we targeted V5 to V7. That would be the most recently mature leaf with a collar. And then we also came in at tassel time and sampled the ear leaf. Looking at grain yield, typically we sample the center 2 rows of each plot of the center part of the plot to avoid the border effect you can have in plots. On a few occasions, we actually harvested all the rows. We got a small plot combine with a scale of moisture, and we corrected to 13% moisture to get the yield. In corn, what we would do, we would throw down a 10-foot piece of PVC pipe you can see in this picture here. We would harvest by hand both sides of the row. We would take that corn back to the research station and shell it out and get moisture and yield on it. We also looked at stalk diameter. So the node above and below where the ear was, we clipped that node and took it back to the research station and got 2 different stalk diameter measurements on that as well to see if potassium was making a difference. Okay, our soil test data for soybeans, this is at V5. The slides will be set up in a similar format, so if you pay attention with that, the K rate is down here on the bottom, 0 to 200 pounds per acre, with the sites below. The y-axis will change. This is Mallet 3K in part per million here. So what I wanted to show you with this slide here, if you notice with increasing rate, we tended to get a stair-step increase in potassium in the soil, which is what you want to see. So we verified, we applied the material, we got an increased level of soil test K as we would expect in the A layer. We go to the B layer. This is now 6 to 12 or 4 to 8 depending upon tillage type. You'll see here, this is Mallet 3K in the soil, that pretty much we have a flat line across these points with a rate. So really, we didn't really see much leaching, if at all, in these treatments for 2017. The same thing in 2016 too. So potassium didn't move in this time period for our study. Looking at the C level, this is the deepest level of potassium. Again, pretty much a flat line across these. So again, documenting very little movement of potassium, if any at all. I mentioned this earlier, but from a plant tissue standpoint at V3 or V5, from a whole plant standpoint, we didn't really see much going on in the plant. It was just too early to sample, given uptake was limited at this early growth stage. So you will not be seeing data from these 2 different growth stages. This is in the most recently mature leaf at R2 2017. The sufficiency level at R2 is 1.5%. So again, we have our rates across the x-axis and K% in the most recently mature leaf on our y-axis. And what you can see is a general increase in K in the leaf. You'll see all but one site was at sufficiency or above. This site here is the Edgecombe County site, a very, very sandy soil with great leaching potential under irrigation. And the 0 there, we were actually below sufficiency. Looking at our yield for 2017. And what we have here with the slide is yield on the y-axis. The K equal to 124, the number, is actually a part per million number that actually was the beginning soil test level in that soil, so that's a 0 rate of K. Then in parentheses is actually the soil test category. H stands for high, M stands for medium, L for low. So the soil test category for that level when the test started. And then below that, R would be the recommended rate of K for that soil test level, okay? So for instance, at Perquimman site, we had a beginning soil test level of 124 part per million. We would recommend at that soil test level 30 pounds of K, K₂O per acre. And what you'll see here, that we saw no yield responses at all at any sites in 2017. The same thing for 2016 in soybeans. No yield response. Okay, we'll shift gears to corn for a minute. This is V5 and V7 sampling. And again, in the A layer, and you can see again a general stair-step increase in K in the soil. Mallet 3K. I'm not going to show you the B and the C depth layer because it's very similar to what I showed you with soybeans with no change. We step into the most recently mature leaf at V5 and V7. Again, we see these stair-step increases in potassium in the plant as we increase rate. Sufficiency here is between 2 and 3% of the leaf, and you will notice a few sites or a few points here below sufficiency. This was that Mountain Hort Research Station site that we had very, very low K in. And certainly we were below sufficiency here early in the year. I wanted to throw this slide in here too to kind of break up some of the data slides, but I showed you early on the effects of potassium on just the stage of development of the plant. And this is all the rates from 0 to 200 pounds, and you can actually visually, if you look at these, see the progression of plant development across these slides as increasing rates of K was applied. This was pretty striking in the field to see. Okay, in the ear leaf at tassel time, you will see with corn that we had a number of different points for different sites below sufficiency, which is around just below 2% up to 3% of sufficiency in the plant at this growth stage. I think the reason for this partly is I think we were a little bit late in sampling some of these sites. Some of these, the growth stage was a little bit beyond tassel time, I think is part of the reason we saw this. Now the question is, was yield affected at this, given what we saw with sufficiency in the plant? Again, a similar setup to the soybean yield slide. We have the low soil test category with a recommendation of 80 pounds here for this site. We only saw 2 sites that were responsive. The Terrell County site, again with a low soil test level, and this Mountain Hort Research Station site with a low soil test level. Otherwise, we did not see any response to K at any sites at all. And you can see that our recommendation here of, I think it's 90 pounds, pretty much, if you look at the 100 bar, which is close to our recommendation, certainly we didn't see any yield difference between the other higher rates. The same way at the Mountain Hort Station, the recommendation there was 100 pounds per acre. At 100 pounds per acre, we actually topped our yield, so our recommendations appear to be on target. We did take a few shots of the brace roots. You think about rooting with potassium and stalk strength and so forth. This is showing some slides at the Mountain Horts Research Station. You can see this is the 0 rate here. You can see the increased brace roots at 200 pounds per acre. This was obvious at a few sites. Then to wind this up this morning, I wanted to compare our recommendations with those of Penn State and also those here in Delaware, the soil testing labs. And the best way I knew to do this was to look at soil test categories. So what you have on the x-axis, we have a very low level or very low category in North Carolina. They don't have it in Delaware or Penn State. They begin their categorization at a low level. And the recommendations for Penn State, they say they're for 50 bushel beans. University of Delaware actually has recommendations for different yield goals of 50 and 75, so those are the different bars you'll see. For Penn State, their medium is really called an optimum soil test level instead of medium. And for University of Delaware, their high is also called an optimum, and their very high is called excessive. I think I've got that right. But the point to see here is that as a whole, at a 50 bushel yield goal, or 50 bushels, our recommendations are fairly similar. We've got the same soil test extractant. We've got very, very similar recommendations. Now certainly when you increase that yield to 75 bushels, University of Delaware is recommending a lot more potassium because of higher demand possibly, and possibly needing more K. I don't know if that's really validated or not, but anyway, they're recommending more potassium. Looking at the corn Recs, again, you will see at the low category, we have very similar, and this is the yield for Penn State of 150 bushels per acre, Delaware 150 bushels per acre here with the blue bar, and the yellow bar is 200 bushels per acre. Again, in the low category, we have very similar rates within about 20 pounds of each other. Certainly this yield goal pushes that up for the Delaware recommendation, but I think given our soil test extractions the same, we have very similar recommendations across our states with that. So the conclusions for our study and what we're thinking right now and what we saw, Our soil test K increased in the surface layers, as you saw, with increasing rate of K applied in both corn and soybeans. The leaching of K applied to the topsoil and to the lower depths was not seen. That's not to say that potassium doesn't leach. It just was not seen in our study in the time period from when we applied it to when we sampled, okay? We did find substantial subsoil K at lower depths, but in this study, we did not document leaching. The rate of K applied increased the soil test K, but it did not influence the K at V3 and V5. I didn't really show you the data for that. The tissue K at R2 was sufficient regardless of treatment in soybeans. In corn at V5 and V7, the K in the leaf increased with increasing K rate and was sufficient, but all of the lowest soil test levels, that one mountain site I showed you. In corn at VT, tissue was below sufficiency for many treatments, but there was no effect on yield. And I think there we may have sampled a little bit too late compared to being right on the spot at VT. So based on our data, our recommendations do not appear to be limiting corn and soybean yields under current management systems. From a management perspective for soybeans, K is best applied as late as possible since uptake occurs late in the season to reduce the risk of leaching. I've actually had growers plant their soybeans and go back and apply the potassium after the soybeans are planted to reduce that risk of leaching losses. For soybeans, and to a lesser extent for corn, I think that soybeans certainly can reach some of that subsoil K, and some of that can be beneficial to the crop. Corn, since it's a shallow-rooted system, to a lesser extent, as far as possibility. We had a number of collaborators with this study. The Corn Growers and North Carolina Soybean Growers Association funded these studies. Cooperative extension agents, we have a number of regional agronomists that work with me in the field, research stations, also a number of agronomic consulting businesses and farm cooperators helped us with the study. So with that, I'll end and say thank you for letting me be with you. Happy to answer any questions that you may have.